Hello everyone, welcome to the third day of our C Programming Bootcamp. So, before I start, let me remind you that there will be an attendance form which will be posted in the live chat at the end of the session. Please don't forget to fill the form for the attendance. And so, let me say the things that we are going to cover today. First, we are going to see about the label and the continuous, the break in the continuous statements, and then the go to statement because they're important. And yesterday I have not able to explain it to you because of time constraint. So once we have understood those, then we are going to see about the functions. The yesterday I have seen a little introduction about the functions. We are going to completely today see about the functions. So let us start. Okay, so this is the Pascal triangle program which I have asked you to try yesterday. So this is how the Pascal triangle looks. I hope you have an idea now as I've asked you to do it. Now now let us start. Hash include std data main, you know them very well. Now I have defined four constants. Okay, I mean three constants and four constants and one coefficient. Yes. Now enter the number of rows. Now once I'll show it to you, I'm going to compile and run it. Okay, the number of rows, let them be 5. Right. The number of rows, let them be 5. So this is how the Pascal triangle looks. In the Pascal triangle, if you know the logic, this particular number in the third line, it is sum of this two numbers. Okay. You see diagonally, and that is the sum of those two numbers. Now again 3 is there. 3 is the sum of 1 and 2, and here 3 is there. Again 3 is the sum of 2 and 1, and again here 4 is there in the fifth line. That is the sum of 1 and 3, and here 6 is there, which is sum of 3 and 3, and again 4 is there, which is sum of 3 and 1. So we want to print this. So whenever we want to print this, we are going to write this particular logic. Now we are going to scan rows. You know this, you have understood this by now. And for I equal to 0 to okay, for I is less than rows, it should always be less than rows. I plus plus, I should get executed. Now now as you know, first I have shown you that there are number of spaces over there. There should be 5 spaces over here because we want to print 5 rows. And if we have more number of spaces, then there will be, it will not look like a triangle, it should look like a pyramid, right? So we are going to give 5 spaces over here. So accordingly, so it should always be less than rows minus I. Now in the first the iteration starts from I equal to 0, so it should print I equal to rows minus I means 5 minus I, that is 5 minus 0, that should be 5. So 5 spaces should be printed, and that is how we wrote the logic. The 5 spaces should be printed. Now that's fine. Now coming to the second nested loop. Now these are the nested loops as you have understood. Now once you have understood that they are nested loops, now again there is a second iteration in the same loop. So for j equal to 0, j is less than I, j plus plus. Now if j equal to 0 or I equal to 0. Now this is nothing but the logical OR operator that I haven't explained it to you on the first day. So this you have understood. See, in the first two lines, it should just be printed 1 and 1 here. So there is no logic. I'm directly asking it to print as 1. So I'm just giving the word coefficient. Now the coefficient is the variable what I think that should be printed. Okay, so that is coefficient will be directly printed. Now in the first iteration and the second, in the first iteration, j equal to 0 and I equal to 0. Now in the second iteration, I equal to 1 and j equal to 1. So it will in the second iteration, I equal to 1 and j is still equal to 0. So it will just be printed once again. And again in the else part, now in the, let's take this particular part. Now in that part, it is just going see, for all these diagonal things, first once will be printed. Now either I equal to 0 or j equal to 0 over there. So I will be okay, for this particular part this will be calculated. Now if let's assume I equal to 1 and j equal to 1. So when I equal to 1 and j equal to 1, there will be it will be like 1 minus 1, that is 0, plus 1 by 1 means 1. So coefficient into 1. So there will be, I mean, when you are going to write it like this, you need to understand that we are updating the value of the coefficient, right? We are updating the value of the coefficient, and because I'm multiplying it over here, see, because I'm multiplying it over here, I'm not giving it as plus. So I wrote it as initially 1. Now if I we can just add it also. No, I meant if you can write this as 0, right? The initial value of the coefficient might be equal to 0, and you can also write it like you can just add it every time, right? You can also do this particular part. So I like to do this in this part, so in this way, so I wrote it like this. If you write 0 and if you multiply it every time, it will just get printed as 0. So I mean 0 into any number is 0, right? So with that particular logic I have written here, I wrote 1 here. So once you have understood this part, now it is going to print 40. Now it is going to print coefficient. So if I want to print it as a particular pyramid, right? So that is the reason I wrote it like this, and it is going to print as in a new line. So after the first iteration, means after this particular part, now again it should print in a new line. Again after this iteration, it should print in a new line. Means whenever I gets updated, it should print in a new line. So I have written in the I particular block itself that it should print in a new line, return 0. Now you have understood how it looks. Now once you have understood how this looks, let's go to the break statement. Now coming to the break and continue statements, these statements are used in loops. The difference between the break and the continue statements is that the break statement will transfer control to the next statement after the loop, right? Break statement and the continue statement will transfer control to the next statement in the iteration. Okay, that is a word we need to remember, iteration or the next statement in the loop. Now I'm going to show you the difference with a small program. Okay, now I'm going to show you a small for loop, and in the for loop I'm just going to change in one place I'm going to write, in another place I'm going to write continue, so that you will know the difference. Now as you know, hash include stdio.h int main, right, again braces. Now again I need to say about int I. Okay, now for loop I is equal to 0, I plus plus. Okay, I is less than or equal to 10. I want to print 10 numbers, right? I plus plus. And once you have done that, let me write braces and then printf %d and comma I. Now you know about this, you have understood this statement. What this will print also, you know, it is going to print from 0 to 10. Okay, it is going to print 0 to 10. I don't want to print 0 to 10. It should print 1 to 10. Okay, I want to print 1 to 10. Okay, now whatever happens it is, you know it very well. I'm just going to execute it again. Okay, break statement, right? It is going to print 1 to 10. You know this very well. Now what I'm going to do is I'm going to write an if condition statement. See how it works. See, it is going to print from 1 to 10. That's fine. Now I'm going to write a if condition. Now if I equal to 4, now means iteration means from 1 to 10 it is going to print, right? Now when I equal to 4, I want to write a condition that it should break. Okay, what will break do, I'll say to you later. Okay, break. Now again, I at the end of the loop means from this statement to this statement it should print again. I want to print end of the loop. Okay, now you will get to know the difference. So please remember, after every statement you need to write a semicolon. For if the conditional statements and the loops, we don't need to write it. We don't need to write this statements. See, after 1 2 3 it has been end of the loop, means when I equal to 4, the statement, when I equal to 4, the control of the statement from 11th line it came to the 15th line, means it is not printing from 5 to 10. Okay, it is not printing from 5 to 10, from the 11th line it came to the 15th line. That is what you need to understand. Now in the same program I'm going to write continue in the new file so that it's easy to understand. Okay, see the next statement in the loop means here as I wrote the condition here, it comes to the next statement in the loop. The next statement in the loop is nothing but the 15th statement. So the controller will come to the 15th statement. Now in the continue statement, what will happen it is, right, continue, saving it. I'm saving it with the name of continue. Right, and the source file is .c. That's fine. Save. Now I'm compiling and running it. See, when you look at this, for only 4 it has been coming to the continue. Okay, after continue means it will not be printed, means this statement will not get executed. Now when I equal to 4, you need to understand that it has transferred the control from 11th line to the I equal to 5. Okay, see the command prompt here. Yeah, see the command prompt here. The number 4 hasn't been printed, and after 4 again 5 can be printed. So at the 10 we got the end of the loop, and in the other part I have saved that part too, right? See, in this particular part, in break statement, what happened? After 3 it came to this particular part, 15th line, and that's it. So that is the difference. Continue statement will transfer control to the next statement in the iteration, whereas it will break statement will transfer control to the next statement in the loop. Now you have understood this. I'm going to go to the go to statement. Now I have explained these words. I have said about these words in the yesterday in the graph. I mean, in the graphic organization. Anyway, I forgot to, because of time constraint, I was not able to say these. Now, coming to the go to statement, I'm going to show you the program directly. Int main, you know this part. And again, now this will make our work easier, nothing else. We don't need to particularly okay. Okay, I have this habit of writing it like this. See, whenever you write keywords, you need to understand that it is being changed to bold. So that is our, it will help us. So it should go to the event statement, means what, what is it? I'll tell you in a little while. So if else, you know this part, this is just the odd and the even program that I wrote for the simple if on the second day, I guess. So go to odd. Now what is odd and even, I'll let you know. Now again for even, we are going to write it as column. Printf, we are going to give a statement over here. It is going to print even number. Right. And again odd, printf odd number. You have understood this. The simple if else program. I'm going to write return 0. I'm going to save it. Now this should be saved in the day 3. Day 3 and its go to statement. Right. And this is .c file, save. And I'm going to compile and run it. Okay, so okay, not a, I should give a number over here. Let me write 15 here. Right, this is simple program. Now right, when I give 15, it is going to check this condition. Now when I write go to statement in this particular if block, it is going to go to even statement. Now when I write even, it means it is I am defining about the 14th line. It is going to check for the word even. Now it is going to control over. Now if this particular condition doesn't get satisfied, you know about the else program. Now else block. Now what will happen? The statements in the else will get executed. Now the statements in the else is nothing but it will go to the odd statement and this got executed. See here again. Okay, first I need to close these files. See, this particular statement got executed. This is how you can write the go to statement. You can write many other programs too. Now once I have understood this part, now let's go to the functions part. Right, so here are the functions. Now functions can be of two types, the predefined functions and the user defined functions. Now the predefined functions are nothing but the library functions, the declarations in the header files and the body in .dll files, and user defined is user customized functions to reduce the complexity of big programs. Now we can use, I'm going to show you a small program before I show you the more about the functions. So let me go to a new file, source file, a basic program about the functions. Okay, I wrote it as hash, I'm sorry. Right, after this hash include stdio.h is common. Int main, you know this very well, and then this braces. Now coming to the braces, I want to write as a program functions, right? Instead of int main, first I need to write about a function. Now coming to the function, I'm going to write it as int add, and I'm going to write it as int. I'm going to define two variables over here. Now what are these parts? I'm going to say to you later the PPT in the next slides. Okay, return x plus y. You have understood this part. Now add 15 comma 30. Right, now each part I'm going to say to you. Now this is a day 3 add function, right? Now this is a .c file, right? Save. So the advantage of this compiler is I don't need to save it every time. When you click on this particular icon, it is going to save. It is going to save, and it is also going to compile it and run it. So you can use this particular icon for all the things, right? So actually I didn't print of anything, it's my mistake. Printf person d comma, and then I'm going to write this over there. Control X, and yeah, I've saved it. Yeah, see, the sum of 15 and 30 is 45. And now again I'm going to show you for another example. Printf %d comma add of 30 comma 45. Right, compile and run. Okay, let me print this in new line. The sum of 45 and 30 is 75, right? 45 and 30 is 75. It should print me 75 and this should print 45. So see, the sum of 45, 15 and 30 is 45, and sum of this, I mean 30 and 45 is 75. You have understood this now. Okay, whether you have understood this or not, let me go to the PPT again. Right, so function definition, function call, and the function declaration. Right, so whenever we do this particular part, I'm going to say it to you later. Now first let me come to this particular file. Now I wrote this file int add int x comma int y. Now this is nothing but a function that I have written. Now what is this predefined function or the user defined function? User defined function. Now why am I calling it as a user defined function? I'm calling it as a user defined function because I am the person who have defined it a function, given something about the function body. I have written it on my own. It is not present on its own, right? So this particular part, exactly what is over there, I have written this. Now when I come to this particular part, now it is going to return something, right? Now here it is written as int sum equal to x plus y. I have just wrote in return x plus y. Both are same. We are just defining a constant over there. We are just defining a variable which is sum of two numbers. So it is a variable, sum is a variable. So I'm just giving return variable. You can do that too. However you are comfortable, you can write it in your own way. Now coming to this, these are called arguments or parameters accordingly. Now coming to this particular part, now let me show you that. Now when I write this statement, now you need to remember these words: the return type, the function name, and the parameters. And then this is the return statement. Now coming to this part, I'm going to show you with this. Now when I write this, this is nothing but a function. Right, function declaration I'm doing. Right, this is a function declaration. Now I wrote a return statement. You have understood that part. Now here also, if you want to write, like if you know how to add two numbers using just two numbers, means using the operation that I have shown you before. Right, open now you remember this operations, right? I'm just going to show it to you again. See, in this operations, now I have shown you this all four operations. The four operations are sum of the numbers, subtraction, these difference of the numbers, and all those, right? So when I'm doing that, I'm defining a constant again. Now again I'm going to print it over here, and every time I'm going to print it, I'm going to write %d again. I'm going to write another constant over here again. So instead of doing this whole part, now I'm showing you for only one particular example. Now there are hundreds of examples. Now you can return x minus y for any operation or for anything like that. You can show that it is going to for any other numbers. See, again I'm not defining two constants, that such that a equal to 15, b equal to 30, and again c equal to d equal to 30, and again e equal to 45. I'm not doing all those. I'm just calling the function, right? Now this is nothing but a function call. Now how do I do the function call? The function call is nothing but, we had defined a function over here in the third line. Now in the third line, the function name is nothing but add. Okay, the function name is add. Now I'm defining two variables over there. It means that I'm going to give two numbers over here. Now what numbers am I going to give? Am I going to give integer numbers? Am I going to give to letters, to alphabets, whatever all those that I'm going to give it over here. Now when I receive two integers, now what will it return? Return x plus y. Now what is this return? Return is nothing but when I am going to give the return value, it is going to give me, this is one block, right? Now from the third line to sixth line it is one block. Okay, that is the reason from 4 to 6 it is giving me some line, right? That is because of the compiler. So when I do this part, it is going to give this value, this fifth line value, the return x plus y value, to the ninth line. That is what you need to understand. To the main block it is going to give me something back. So when we go to a function, we give the return gift, means someone that person is giving me something back. So it is a return thing value. So that value will be coming over here, right? That value will be printed over here, which is printing me 45 here, which is printing me 75 over here. You can do hundreds of operations which should print x minus y. For suppose I'm saving it, I'm compiling it and running it. You know the answer, 15 minus 30, I'm going to give it as minus 15. And again here also I'm getting it as minus 15, 30 minus 45. So you have understood this part. So this is about the basic about the functions. Now we call them these two parts as arguments, and whenever we are going, this is nothing but a function call, right? Now this is nothing but a function call. We are going to give the parameters, whatever values we want to pass over there, we are going to write our values, right? So we are going to return some value so that it can print something. So when you don't add the printf statement, the return value will not be printed. So whenever we want to print something, we are going to use the printf statement. There is no confusion about this. I have made a small mistake in the middle. Please avoid doing that. Now there is nothing but a function header. Now this has the return type. Now in the same way, many of the functions return some value. So we use int and the function name itself. So you can use void also, where it is going to be used. Let's not talk about it right now. So you have understood this particular part also. Now coming to the next part, next slide, the function definition. When we are going to use the function definition and the function declaration, now again it is the actual function that contains, okay, that contains the code that will be executed. So what I have done in the first 3 or 4 lines is nothing but a function definition over here. From the third line to the sixth line over here, means this whole part is nothing but the function definition, right? You remember this word, a function definition. Definition is nothing but what it means. I'm going to give it, right? What in the English language also, definition is nothing but what it means. We are going to give it about the function definition, right? So the function definition is clear. Okay, what it should execute, that we are going to give it over there in the function definition. It should be identical to the function prototype, right? Now once you have understood that part, syntax of the function definition is return type, means we are going to write the data type over there. Either it is a char character, means alphabet, we are going to use char, right? So we can write char, we can write void, we can write int, accordingly we can write. Now the function name that I have used here is add. So the function name is add. Now the arguments list, we are going to write it as arguments, right? So the arguments are nothing but I have written over there int x and int y. I'm defining two variables over there. Now I'm going to give you the declaration, statements, and the return expression. Now these are all the optional part. The part which is required for me is nothing but the return expression. So I just wrote the return expression. Now you can write the statements. Statements are nothing but when you are writing bigger functions. Now when you are writing bigger functions, we need to execute some statements, the bigger operations like x minus y, x plus y. I want to do the operations between the x minus y and x plus y. So and then I'm going to return that value, right? So you might get it out. Sir, you have written already the operations where I'm performing the operations. And again, why are we writing functions over here? So the first thing is it will make our work easier. So as I said to you, we can give different parameters, different numbers for the same function, and we can do the function call infinite number of times for any number of times, so that we'll get the value. So it is very easy in fact. So instead of defining variables, and we can reuse, that is nothing but the reusing of the function. And the other use is that when we are going to when let us assume we are working on a particular project. Now how to differentiate, how to divide works between those people, so you can use functions. So with the functions, you can say my colleague 1 will do this particular function, my colleague 2 will this particular function, my colleague 3 will do this function, I'll do the fourth function. So when we are going to use functions, we can do for infinite number of times. And there is also a concept known as modules and packages. Okay, now that is nothing but when you write one particular function, you can use that function in more than one particular C file. Now let us not get to about it because it is a long part, right, which I haven't explained it to you yet. Now uh, you might learn it in your near future too. Right, variable and scope lifetime, scope and lifetime. Okay, now why do we use this return function? Everything we are going to learn in this particular part. Now, the scope of a variable refers to that part of the program that may refer to a variable. The lifetime of variable refers to the time in which the variable occupies a place in memory. Now, the scope and lifetime of variable are determined by how and where the variable is defined. Now, I'm going to show you a very small program, right, where this is going to be useful and where we are going to see. Right. Now in the first day, you remember that, okay, before I get to this program, let me complete 2 or 3 slides. Okay, that will be easier for you. Types of scope, there are function declaration, local and global. Now again, types of lifetime, there are local and global lifetimes. Right, before I go into the storage classes, let me speak about this. Right, Control Tab. Okay, now here I'm going to say about the local and the global variables. Now how it is going to be changed from local to global, you need to understand. Right, again. Now this is nothing but the documentation part. I shown you in the first day how a C program looks, right? Now this is nothing but the pre-processing statements or the header files. Now after this particular statement, it actually has global declarations, right? When I say about the global declarations is nothing but which is something where we constant for the whole program. Okay, how it is, I'm going to say you int a equal to 15, right? Int a equal to 15. Now this is nothing but the main block, right? I'm going to print okay, let me write another function over here. The name of the function is print, right? Print. Okay, only one particular thing. I don't need to define anything also actually. So I'm going to say printf %d and a, right? Okay, before I print this, let me write over here function, right? It is going to print in a function. Now I'm going to say this in a now once I run this, you'll get to know what I'm trying to say. Right, local and global dot c. Why is it printing in day 1? It should print in day 3, right? So C bootcamp day 3. Right, save. I have saved this. I'm going to run this file. Right. when we do it like this for a okay, before I do this, one second, I have made a mistake again. I want to print okay, I just need to call print statement. As there are no arguments here, I don't need to pass any parameters. Right, I'm saving it, I'm compiling it and running it. Right, I forgot a semicolon over here. So you need to understand that now the a value 15 here is being printed by the function. The function actually doesn't know the value of a. I haven't defined any constant over here that a equal to 15. Now in the main block also I haven't defined a constant that a equal to 15. So how is it taking the value of 15? Now when I write it over before this main function in this function, it is going to understand the 15 value. The a value is for the whole program. Okay, the a value is for the whole program. Now let me write another part. Now this is nothing but a global variable. The global variable is nothing but it is for the whole program. Now whereas if we write a local is nothing but I'm going to define something here. Let me write int b equal to 20. Okay, now that is the only change that I'm making. Now if I want to print, now this int b equal to 20 is only limited to this particular main block. Okay, that is only limited to this particular main block. Now if you don't understand that, try to print the value of %d. Let us try to print the value of b over here. Now we need to understand that it will not be printed. I'll get an error that b is undefined over here. Now why do I say it undefined? Because this, as I said to you, this b value is only defined to this particular block. This particular block means from the 10th to the 14th line. Now after this, from 14th line again you write something else. B is not defined, and again here over there from 5 to 8, from 1 to 8 in fact. Now if you write B value, it is not defined. Now again I'm going to compile and run this. See, B undeclared first using this function means it will not understand that the B has been come here. I mean B value has been here, so it should come here. Means it is only local to this variable only. Alright, it is only local to this variable. Now if you want to write int b equal to 50, int b equal to 20 over here, it is going to be defined for the whole program. Now in this particular part, it is only for this part, right? Only for that particular block. Now again if I write int b over here, now these are local variables, right? That will be now if I write int b equal to, let me write 20, right? When I write int b equal to 20, see, now I'm going to define this with the same name. I'm going to define two variables but in two different blocks. How it is going to react, we will get an idea. Print %d. I want to print the value of b, right? Okay, I'm printing b here also. So how it is going to react differently? So again let me write, because of the, okay, I've already wrote the statement before. Okay, now this is from the function. So as it is from the user defined function, I'm going to write it like this. If it is main, it is not going to print anything. So compiling it and running it. See how it is going to vary from the first. So there is some issue with my compiler. So Okay, there is some problem when it went to an infinite loop. Okay, anyway, for the main function we need to understand that it is the value is 15, right? This value is 15 over here. Now wherever you are printing it, it is going to print as function is value is 15. Now here the main value is 15. Now when we are going to do this particular part, in only in this particular part the value is here is 20. Now in the other part, okay, let me write it as 25 over here. Control X, I'm going to compile it and run it again. Okay, it has went to an infinite loop. I don't know the reason. Okay, now again in this particular part the value of b is 25. In this particular block the value is b is 20. Now first, whenever we are going to write this part, we need to understand that it is going to check for local variables. It is going to check for local variables. Now local variables are nothing but the variables that has been variables or a content that has been instantiated or started in that particular block. Block is nothing but you can see with the braces. So that is the reason we use braces. So in that particular braces, if it has any value, that value will be printed. Now if it hasn't, if there is no, if that is not defined over there, the control will go to the third line. It will check for the global variables or the global constants. Right? When it is going to check for the global, it is going to print that value. Now once we have understood this local and the global part, we are going to come to this particular part. Now the scope and lifetime is nothing but you have understood this part. Now coming to the storage classes. Storage classes is nothing but now there are different types of storage classes: auto, extend, static, and disaster. Now coming to this part, auto is inside a function or block declaration location. Now scope is within the function or the block. Now you can call it anything as a function and as a block. Okay, that is the reason every time the function and the block word is written, there is a slash between them. Now you just need to read this and you'll get to know about this. This is static or global variable. Now once we have understood this, let's skip to the recursion part. Okay, now recursion is nothing but a function calling itself. Okay, now whenever someone asks you, whatever the language it might be, it is nothing but when a function calls itself, you call it as a recursion. Now a recursive function performs the tasks by dividing it into the subtasks. Okay, so there is a termination condition defined in the function, which is satisfied by some specific task. After this, the recursion stops and the final result is obtained from the function, returned from the function. So the case in which the function doesn't recur is called the base case, whereas instances where the function keeps calling itself is called a perform a subtask is called the recursive case. All the recursive functions can be written using this format. Right. So this is how we are going to write the int recursion. Now this is nothing but whichever function you are going to write, this is nothing but the arguments part. Now, so the int recursion part, this is nothing but the arguments part. Now once it is coming to the return. Now or else it should print a return x minus 1. So first let me show you this particular function only exactly I'm going to write. So let us see what answer we are going to get. I mean, what result we are going to get. So instead x, yeah. So instead of remembering everything, I just want to hit what it should be printed. In recursion if x equal to 0, right? Okay, I'm going to new source file. Right, the file name is that recursion. Let a simple program on recursion. Now hash include stdio.h int main. You have understood this part. After this, and then what we are going to do is that what I've done here, int recursion if x equal to 0. Okay, now right, in recursion I'm defining a function over here. Okay, when I'm defining a function, it should be printed in the other place. Right, int recursion. Now it is going to if x equal to 1, right? If x equal to 1, if x equal to 0, then return, else recursion x minus 1. Okay. Okay. We can write like this also, return and semicolon. It means nothing but, okay, else it should print the number. Right, print the value of x %d. Let me write it like this so that you'll understand a little bit, or else it will be Greek and Latin for you. Print %d, and what I'm going to do is recursion of x minus 1. Okay, here I'm going to call recursion of 15. Now once the program ran, compile and executed, I'm going to show you how it is going to change. Now instead of 15, let me write 10. The program name is recursion. Right, and this is nothing but a .c file. Save. Right, compile and run. Okay, forgot a semicolon here. Return 0 over here, or let me write return 0 over here. I am not able to detect the error over here. Okay, there is some error. Let me check it later. Right, let me check it later. So, okay, I wrote it as print here. Printf. Say I saved it. Now compiling it and running it. So let me check what will come here. So it is printing from 10 to 1. Okay, let me do another thing here again. So what is happening here, I'm going to show it to you. It is going to print in a new line. From 10 to 1 it will be printed. Now what is happening here, you need to understand that first I made a function call over here. Like I made the function call over here. Now when I make the function call, it is going to check. Now what is it going to check? If x equal to 0. Now this it will going to check in this line. Is x equal to 0? No. So if x is not equal to 0, it is going to print that value. Right, it is going to print that value. And again what is happening here, I am making the function call in the function call itself, in the function itself, in the function definition itself, I am making the function call again. Now what function call I am doing, it should be, recursion should be done for 10 minus 1. 10 minus 1 is nothing but 9. So again it is going to check if 9 equal to 0, it is not. So it is going to print the value of 9. So it is going to come again and again. Now what is the end condition? This is the end condition. If x equal to 0, it should return 0. So we can write return statement not only at the end of the file. If it should go to the end, I mean it should stop working, then also we can write return 0. Now instead of return 0, you can also write break statement. I said you about the break statement, right? We can also write a break statement over here. So when I write the break statement also, that the same function is going to happen. That is about the recursion. See, the function is calling itself. So this is called nothing but a recursion. So you have understood this part. Now let's go to the next part of the PPT. Right. So the idea is the base condition and the recursive call. Now in the function that I have shown you in the C program, the base condition is nothing but it is going to print. I mean, the base condition is nothing but if condition, the if block over there. And the next part is that the recursive function call. Now the recursive function call has already been defined to you that it is going to print the statement, and the recursive call, recursive, and the x minus 1, that is nothing but the recursive function call. Right. Now you might have thought, okay, with the for loop also I can write this. With the while loop also we can do this part. Now why haven't I done that? Okay. Now many of you don't know that. You actually need to try this part. Now let me tell you. Now when I write, let me open a file. Open. Right, in the day 2 itself, I actually should have shown you another part, but fine, no problem. In the okay, I open .exe file. Okay, open for loop. Okay, now it is going to print. Now this function is for loop. Now this is going to just increment the values, right? Now there is another option too. Incrementing, it should decrement, right? This is known as decrement. Now this is also an operator. Anyway, when you write I minus minus, it is going to print from 1000 to 1. See how it is going to print. I'm saving it, Control S. Now I'm going to compiling it and running it. So it is going to print from 1000 to 1. Okay, I have made a mistake over here. Right, it will go to an infinite loop, so that is a mistake. Okay, when it is equal to 0, it should be stopped, not less than 0. When it is equal to 0, it should be stopped. Okay, 1 second. Now int, the initial value is 100. Let's suppose now if this is the case, it is going to print from 100 to 0. It is going to decrement the values. Okay, there is some error with my Dev C++ compiler. Anyways, now you can do this part. Now you have understood what I'm trying to say. When I equal to 0, that should be stopped. Right, when I equal to 0, it should be stopped, and I minus minus, that value will be decremented. Now when you are going to write the program like this, it is going to print the values. Now what is the difference between this part and this part? We are writing a loop over here. Now the recursion is calling itself. In the 10th line, we are calling the function again and again. I haven't written a loop over here. Now that is the difference. Now this is a function. Now whereas this is not a function, this is just a while loop. So anyway, iteration and recursion. So iteration explicitly uses a repetition, right? A repetition structure. Now we can write a for condition, the iteration statement in the function also. That is nothing but an iteration function. And in the recursion, I have shown you the function itself. So the recursion achieves repetition through repeated function calls. Iteration terminates when the loop continuation. Recursion terminates when a base case is recognized. Base case is nothing but, in the example that I've shown you, if it is equal to 0. Iteration keeps modifying the counter until the loop continuation condition fails. Now the loop condition fails is nothing but in the I equal to 0 we have written, right? So when I equal to 0, it should be stopped, right? In the second program. Now recursion keeps producing simple versions of the original program until the base case is reached. Iteration normally occurs within a loop, so the extra memory is omitted. Recursion causes another copy of the function, and hence a considerable memory space is used. So you need to remember about the memory too, the space complexity. Now, if it is more of space complexity, that particular part is usually not a preferred. Okay, that part is set you in the advanced stage. You're just in the basic stage right now. So it reduces the processor's operating time. It increases the processor's operating time. And you must have understood the whole part today. Thank you for attending, guys. That's it for today. So before you exit, now there will be a Google form which will be posted in the live chat, and please don't forget to fill the form for attendance. Thank you, everyone.